Now, I'm going to have to be completely honest with you and admit that some of the things that I'm going to be discussing in this section are getting us into pretty deep waters. In fact, if there'd been a way to avoid some of these topics and put them off until later in the course, then I'd have taken it. But there really isn't, because we need some reliable way of getting input from the command prompt, and there's really nothing to do now but to go ahead and code it. So I'll be talking about some quite complicated things, from null terminated strings, buffers, buffer overruns. I'll be talking about overwriting bits of memory, things that if you haven't programmed in C before, or even if you've programmed in some other languages that are more protective of your code, that can prevent you from having to deal with memory management and the sort of problems that you can easily encounter using C, then you might find some of the information and some of the techniques I'm talking about in this section quite difficult to understand. Don't worry, I'll be going over a lot of the nitty-gritty details of strings and memory management and so on later in this course. So if you don't understand it now, come back to it later when you've studied the later sections. But even if you're not interested in understanding all the technical details, look upon this as an example of how a programmer in C would work, because I am starting with programs that work up to a point. When I use gets, it worked at first, and then I discovered problems. Then I switched to fgets, and that seemed to solve one problem, but it gave me some more problems. And so each time I work back on my code, I've had to refine it. I've had to find problems and deal with it. So even if you don't understand all the technical information I'm providing in this section, look upon it as an example of how programmers work, how you need to analyze your code, find problems, and rewrite to refine and improve your code. In my last video, I mentioned that sometimes when we try to read more characters from input than will fit into a fixed size array variable, those characters remain in memory. Here I want to explain as simply as I can what's going on. Let me just remind you of the problem. So this is 03_getinput, build and run project, and I just enter more characters than can be used to initialize the variable first name, which is declared as an array of 5, and you can see that some of the characters are used with the first variable and some of them are read into the second one. So let's explain this. It turns out that when the user types in characters at the command prompt, those characters are put into a storage area or buffer that contains data waiting to be processed. So when I call fgets to read in data, it reads it from this buffer. Any data that isn't read, that is, any extra characters in the buffer, hang around waiting to be processed. So if I call fgets a second time, the next characters in the buffer will be read, even if the user has subsequently gone ahead and entered some new characters at the keyboard. That new data won't be processed until the characters waiting in the buffer are processed first. That explains why in this program, when I enter more characters than fit into the first name variable, those characters are immediately read in from the buffer by the next fgets here. And they are then assigned to the next variable, last name. But that isn't what I wanted to happen. What I wanted was for any extra characters to be truncated when the first variable was assigned, and only any new data entered at the command prompt to be assigned to the next variable when I next use the fgets function. In order for that to happen, I need to empty the buffer first to get rid of any characters that it already contains. In fact, there may be a built-in function that will flush the keyboard buffer for you. On Windows, rewind with the parameter stdin will do the job perfectly. And so will flush, again with stdin. However, on some C systems, F-flush only works with output, not with input. But there may be other functions, such as TC flush. However, some of these functions are non-standard. They're not going to be available on all systems with all C compilers, so to be on the safe side, it might be better to write our own buffer flushing routine. And that's what I've done here. Let me comment this out and uncomment these calls to my routine. So these call the flush input function after fgets. Let me look at that function which I've written up here. All this does is it reads through the remaining characters in the buffer. It reads them up until it finds a new line /n character, which indicates the end of input entered at the command prompt, that is the new line character that's appended when the enter key was pressed. In fact, I also test here for the end of file. That's a negative integer value assigned to the EOF constant, which ensures compatibility with attempts to read lines from disk files, should I so wish. The exclamation mark equals operator here means not equal to, so the while loop continues reading characters from the buffer while the character that is read is not a new line character, and, that's the two ampersands, and it is also not at the end of the file, EOF. So now I can enter more characters than fit into my fixed length array variables, and the extra characters are used up by the flush input function. So when I next enter data, that is what's assigned to the next variable. Well, that's the theory. Let me try it. Build and run. Once again, I'll add these numeric characters, which are more than will be assigned to the first variable, and some alphabetic characters. So all looks well and good. Well, up to a point. There is still a problem here. Look what happens if I run this again. When I enter fewer characters than are needed to initialize the variables. This time I have to press the enter key twice for each of those two fgets data reading function calls. Now that's because fgets reads the new line character itself. Let's go back and look at the code down here. So that's the new line that was entered when I pressed the enter key. But remember that my flush underscore input function carries on reading characters until a new line character is found. But there is no longer a new line to be found because I've already used up that character in my call to fgets. So that's why I've had to press the enter key twice. Now I could rewrite this code to try to deal with this, but I'm already starting to find this quite confusing. And when your code starts to be confusing, the time has come to simplify it. I've decided the best thing to do is to write a better line reading function that handles all the complexity. And that's what I've done in my next project. In fact, there are two different versions of this function here, which I'll explain shortly. So I want to read a line of text up to a maximum specified length. And I want this to work exactly the same way whether I enter a short bit of text, a long bit of text, or even no text at all, if, for example, I just pressed the enter key but didn't enter any characters. And as an added extra, it might be useful if it also returned the length of the text that was read in, just in case I need to verify the length of the string for some reason. And I'll explain all this in more detail in the next video.